Maya rode in a car to her friend's house and averaged 30 miles per hour. She walked home averaging 3 miles per hour. The total trip took 3 hours and 18 minutes. How far away is her friend's house? Well, the first thing I want you to realize is this problem is going to use the equation D equals RT. Distance equals rate times time. Because we're given a rate and a time and we want to find a distance. Now, before I do anything else, I realize this is in miles per hour. It's a rate and it's in miles per hour. And this is in miles per hour, which means our distance has to be in miles and our time has to be in hours. And I look here and my time is given as 3 hours and 18 minutes. So I say T. Now, total time is the time there plus the time back equals 3 hours and 18 minutes. Okay? And immediately I realize I need to do something with this. Well, this one's already in hours, but 18 minutes is not. Well, how many minutes are in an hour? The answer there is 60. So this is 18 over 60 hours. So this is 3 and 18 over 60 hours. And I can reduce that to either 3 and 3/10 or 3.3 hours. If you prefer a fraction or a decimal, either one works. So that's the first thing I have to do. Now, that's kind of an aside. Go back to the original equation. I realize that the distance to her friend's house has to equal the distance from her friend's house back home. So D1 equals D2. And D equals rate times time. So this is going to be rate 1 times time 1. And this will be rate 2 times time 2. Well, rate 1 is 30 miles per hour. I don't know time 1. And rate 2 is 3 miles per hour. And I don't know time 2. So what I'm going to do is I'm going to basically substitute. Okay? I'm going to basically substitute here. And I'm going to say, okay, well, solve this equation here for time 1. So this equals time 1. And here, this equals 3.3 minus T1. 3.3 minus T1. Now, how did we get that? Well, the way we got that is actually really simple. What we did was we took the equation T1 plus T2 equals 3.3 hours. And we said, okay, get T1 by itself. So we move T2 over. We get T1 equals, or in this case, T2. Solve for T2. T2 equals 3.3 minus T1. Everywhere you have T2, you can put this quantity. And that's what we did. We substituted that where we originally had T2. Okay? So now, we've got this, and we have one variable, T1. Well, 30 times T1 is 30 T1. And 3 times 3.3 is 9.9. And 3 times T1 is minus 3 T1. And so there's our equation. Solve this for T1, and I get, if you take 30 minus 9.9, you get 20.1 equals, like terms here. 30 plus 3T1, you get 33T1 equals 9.9. And if you divide both sides by 33, you get T1 equals 0.3 hours. Now, what does this mean for us? This means the trip to her friend's house took 0.3 hours. Okay? Well, what do we know about the trip to her friend's house? We know that the distance equals 30 miles per hour times 0.3 hours. And what happens? Well, 30 times 0.3 gives me 9 miles. And that's actually what we were looking for here, is the distance to her friend's house. Well, what about the trip back? Let's double check our original assumption. What about the trip back? Well, the trip back was at 3 miles per hour. And this is T1. Well, the total time was 3.3 hours. Right? T1 plus T2 was 3.3 hours. So if time 1 is 0.3, time 2 must be 3 whole hours. And 3 miles per hour times 3 hours equals 9 miles. So Maya's house is 9 miles from her friend's house. And that's how we solve this problem. If you have any questions, please come see me.